Good morning to everyone. Today I discuss the topic on generation of FM. How FM can be generated. The circuit which generate the FM signal is called the FM modulator. So FM modulator is a circuit which generate the FM signal. Okay. FM modulator is a circuit which generate the FM signal is called the FM modulator. There are two methods to generate FM signal. First is direct method or parameter variation method. Direct method is also called parameter variation method. And second is indirect method. It also called the Armstrong method. Okay. So first we discuss the direct method. So what is direct method? Now modulating signal is directly modulates the carrier. Modulating signal is directly modulates to the carrier. Okay, is called the direct method. Directly modulates to the carrier. Okay, and the carrier signal is generated with the help of oscillator circuit. So in the modulating signal is modulating signal, but carrier signal is generated by the oscillator circuit. There are LC circuit used to generate the oscillator, LC circuit, whose frequency formulation is omega c is equal to 1 by LC. If L and C is vary, the frequency is also change. Okay. If the value of L and C is vary, is change, the frequency is also change. So oscillator basically circuits which generate the frequency. Here to generate the carrier frequency, oscillator is used, whose formula is omega c is equal to 1 by root over L by C. Okay, so omega c is directly vary with the modulating signal xt. Okay, omega c is directly vary with the modulating signal xt. Modulating signal is denoted by xt and omega c is the carrier frequency. So carrier frequency is directly depends on or directly vary according to the modulating signal. So it also called the parameter variation method because the carrier frequencies change when the value of LC is changed. When the value of L and C is changed, the carrier frequency is also changed. So it is called the parameter variation method. The parameter is variates, means parameter is changed. L and C is the value of L and C is changed. So it is called the parameter variation method. L and C is called the parameter. Okay. So parameter is vary, means the value of LC is vary. Okay. So an oscillator circuit whose frequency is controlled by a modulating voltage, means if voltage is changed, frequency is changed, means the frequencies depends on voltage. It means when voltage is changed, frequency is changed, is called the VCO, voltage control oscillator. Means control the frequency when voltage is changed. Okay, so it is called the voltage control oscillator. Means frequency is vary or frequency is depends on voltage. If voltage is changed, frequency is changed. So it is called the VCO, voltage control oscillator. Okay, so how frequency is changed? Now, if the value of LC is changed, frequency is changed. If the value of LC is changed, frequency is changed. Because from this equation, we get if the value of LC is changed, omega c is changed. Omega c means carrier frequency. So, if we vary the value of L and C, carrier frequency is changed. So, we vary the value of capacitance or we vary the value of inductance. So here a value of capacitance is vary. Okay, how the vary the capacitance value? Here voltage variable capacitor is used. Voltage variable capacitor means when voltage is changed, the capacitance value will change. Here a varactor diode is used. Varactor diode means variable capacitor. When voltage is changed, the diode capacitance is changed. So if the capacitance is changed, the frequency is changed. Okay. So variable. So it is called the varactor diode, means variable capacitance. Varactor diode is a semiconductor diode. Okay. Next, okay, the varactor diode is a semiconductor diode whose junction capacitance, okay, whose junction capacitance change with DC bias voltage. Okay, if the DC bias voltage is changed, the junction capacitance is also changed. Okay, so this is the circuit diagram of varactor diode method of FM generation, which is direct method or parameter variation method. They are the DC bias. Okay, this is the DC bias for used V0, and this is the modulating signal. And here a resistance is used to protect these circuits. Okay, so this is the varactor diode. Okay, and here a capacitor is used, and this is a TAN circuit which generates the oscillator circuit. This is the LC TAN circuit. Okay, so we discuss how to change the frequency. Okay, how to generate frequency or change the frequency. If frequency is changed, so it is called the FM. So junction capacitance, okay, CD means this is junction capacitance of the diode. CD, junction capacitance of the diode. The expression is equal to K root over V suffix D. Okay, where VD is equal to total voltage across the diode. Okay, total voltage across the diode. It is called the VD. Okay, total voltage across the diode. So CD becomes and K is called the constant. Okay, so voltage across the VD, CD is called the VD, means voltage across this diode, varactor diode, is called the VD. So CD becomes, equation becomes K V suffix D equal to minus half. Okay, this is the root over means K by VD to the power half. If the VD is above, so VD is equal to minus half. Okay, next we discuss what is VD, value of VD, V suffix D. This is the value of VD. Okay, what is the value of VD? VD means V0, biasing voltage V0 plus modulating signal voltage XT. So two signal, this is the V0 signal and XT signal goes to the varactor diode. So voltage across the varactor diodes is the sum of DC voltage and the modulating signal. So VD is equal to V0 plus XT. So oscillation frequency formula, omega C is equal to 1 by root over LC. Okay, so here is called the instantaneous frequency. Omega for frequency modulation is called the instantaneous frequency. Okay, which is 1 by root over, here L means in the circuit, L means L0, here L means L0, so here we note L0, and C means total capacitance means here are two capacitance, C0 and CD, two capacitance C0 and CD. The neglect of value of C, because this is very small compared to the CD and C0. C is very small compared to the CD and C0, so C is neglect. So total capacitance value C is equal to CD plus C0. Total capacitance value, there are two types of capacitance, C0 and CD. C is very small compared to this, so C is neglected. So total capacitance value CD plus C0. So LC, C means CD plus C0. Okay, so if CD is vary, if voltage is vary, so junction capacitance is vary. If junction capacitance is vary, omega I is vary. So value, so omega I is equal to omega 1 by L0 CD. The value of, put the value of CD. CD means K VD to the power minus half plus C0. Okay, this is the method of varactor diode modulation method, variable capacitance. If the voltage from this equation we get, if VD is changed, CD also change. If CD is changed, omega I is also change, means the CD is change, means this value is change, this value is change, means omega I is also change. So variation in frequency or frequency is change, so it is called the frequency modulation, and it is the method of generation of FM modulation method, which is called the varactor diode method of FM generation. This is the direct method. Next we discuss the indirect method in next lecture.